Resonant transformer, explanation and construction, transaction, construction. Movie, sponsor of program, Douglas Konzen, stage operator and producer, Svetlana Konzen, director of all staff, Douglas Konzen, by Svetlana Konzen. Movie beginning. Enjoy the video.
Okay, here we go again. I think I have a good explanation that people might be happy with. First of all, it's getting AC fed into it, this transformer here. It's a three-phase transformer core, but only one phase receives AC power, there's one on the left. So, if you think about it, as on the north, it's only going to be the north half wave. It's only going to be the peak and before it and after it to some degree, about this much, where it's going to be absolutely going to be a north polarity to the core. We're talking about the core here. So, and then there won't be anything here, of course, and it's kind of dipping and then it's building. But up here, so figure this, so it's going to be north and south and north and south, okay? When this is north and south, the first half wave would be this. Now, it's going to go over here and make this south and make this north, and then you have a little loop, magnetic loop going on here. And then this would also be like this, okay? Now, the way it works is in order to get rid of the back EMF, the back EMF would be here, because here's coming in, and it would be shooting this way. And it would be a south. It would be south. Okay, just a minute. Alrighty, so hope this makes some sense. We're still working with this half wave of north, positive. And so the back EMF goes opposite of current flow. So it's going to shoot over this way, but guess what? It's blocked because this has been induced south. As in I just explained, when this is polarized by the AC coming in, the first half wave here is going to make this north. It's going to make this south and this north. And so when the back EMF goes this way through the core, it might want to go into this one as the forward current is, but instead it's blocked. So it continues through the crossbar. Maybe you could call this a shunt bar, but it's going to end up over here now. And guess what? This is north now, and it's going to attract this south opposite to north back EMF. So it's going to attract that into there. And all of this happens on the flip side too, when the polarity of the AC changes. So it's kind of, you can say it's kind of a magnetic block, and it guides the back EMF into this far core leg over here. Now the trick would be, in order to have it fast enough, or this will be at 60 times a second, 60 hertz. So you want the back EMF from here going in this way, coming in this way, and you want the back EMF here coming in this way, so it collides within this area over here. Might collide up here, might collide down here, might collide right in the middle, but the collision of the back EMF will eliminate it. And now you don't have the back EMF problem of when you load this, the normal transformer action, when you load the secondary, it creates back EMF that fights the primary current flow, and it raises the draw huge amount according to how much load you have. And you don't want that. You want this to be kind of isolated from each other, and you want to send that back EMF over here. So I think that's pretty good explanation. It gets blocked from wanting to go into here, and it shoots its own way through the shunt crossbar into the far end, and it works all, it works this way and it works this way, same as I'm doing here, except everything opposite. So there's that. And I'm going to be testing this pretty soon. These are very high ohms. And I have a feeling the ohms are so high it's just not going to send too much current in there. Like the middle one's 473 ohms. This one's 422 ohms. 4 henries though. 3.8 henries. 3.6 henries. And over here it's 377 ohms and 3 henries. So the primary I have is the most inductive coil. And we'll see how this works. I'm going to go outside here just a bit. Hold on a bit. Okay, so here's another one I have going on. And see, I made the coils in a jig, and it's masking tape and epoxy. And I made this one kind of too big. So what I did is I have 4 layers of this 28 gauge wire, up and down, wrapped it with Teflon each layer. So that's going to be right against the core. I didn't plan this, it's just that I made this too big, so that'll be interesting. And then these are in series and in phase. The inner coil and the outer coil, I checked that out, so they're in phase. So this is going to be the primary. This is going to be the secondary that's going to be connected to the load. This is similar to Tim Tron's latest, where he had about 10 times over unity into a heater core element with nichrome wire. And Tim Tron, Timtron, all one word. Just look it up on YouTube. He just released a whole bunch of videos of his looping, self-running motor gen thing, and a lot of stuff going on over there. And he likes people to join his Patreon. It doesn't cost very much. unless you want it to, and then you can communicate with them and learn a whole bunch of stuff. So this is a little more hopeful to me. I have a feeling this is going to work pretty good. And it's the same thing. This is a primary, secondary, and this is the back EMF shunt bar. This is 88 ohms. This is 75 ohms. This is a huge 667 ohms, and I don't even know if I'm going to use it. But it'll be interesting. And all of these slip off. I can change them. These over here are on the one I just showed before this, with the skinny little coils. These are other coils I made because I'm expecting that not to work so well, because it's not really going to jam a lot of current through there. And so after I test that to see how it goes, I can put these in there and see how these go. And one more thing, the way it works, how I understand it or misunderstand it, is you got to put this whole core into ferroresonance, where the whole core is vibrating like crazy. And you usually don't want that to happen, because it's going to heat up the transformer. It's going to blow out everything because the voltage produced will be so high. But you actually want that to happen. You want this primary to create ferroresonance so that power transferred from here to here is done via ferroresonance. So you get a lot of power, more than if it was just the normal transformer action. A lot more. And if you get rid of the back EMF, then you can sustain that ferroresonance, and it'll be of greater amplitude too, both voltage and current, much greater amplitude. And if you get rid of the back EMF, you don't have this magnetic force fighting the current flow, so it's going to stay kind of cool. You're not getting rid of the back EMF makes it so it sustains, it has greater amplitude, and it's going to keep it cool, not overheat. This is my theory. You can disagree if you want, but that's how this is. The requirement is this creates ferroresonance. This is the secondary that goes to the load. Whatever load you want, you have to. Some loads are not going to work, some will. Timtron has a heating element, nichrome wire, and I'm probably going to use resistors, and I do have a heating element, and so there's three types of loads I can think of. There's a capacitive load, where you just fill up a capacitor with this thing and then float the capacitor, dump it to a load. Or you can have an inductive load, where like a motor or anything that's inductive, like it's a coil that is the load. Now with that, you need to have know the phase shift and everything in order to calculate power. But just running a motor with this, which is an inductive load, is something to think about and do. And then there's just a plain resistive load, just a resistor. And that's the way power engineers want to see. They want to see just a straight resistive load. They don't want to see anything out of the ordinary going on. So now you can use Ohm's law to calculate power coming out of the secondary. So I think that's about it, and I'm sorry I haven't begun testing yet, but I'm kind of slow. There's no big hurry. I'm not under contract or anything. But hopefully tomorrow I should have a video up testing this. I have high hopes for this one. I have low hopes for the other one, unless I put these coils in, but who knows what's going to happen till you test it. So, I guess that's about it. And I hope my explanation how this works is acceptable to the human mind. So, because it's crazy how much power, 10 times over unity, 60 watts in, 600 watts out, that Tim Tron got. I'd be happy with just 2 times over unity. So that's about it. So thanks for watching.
Thank you for watching. Thank you very much. Bye.